Have you ever just stopped and looked around and noticed how everything is always changing? Sometimes it's slow. Other times it happens right before our eyes. Well, today we're going to be detectives. We're going to uncover the secret process behind all of it. So let's get started on our investigation into this incredible world of change. Okay, our very first case file, it opens right in your kitchen. I mean, think about it. You bring home groceries, and some stuff seems to last forever in the pantry, right? But other things, they spoil in just a few days. So why? What invisible force is making this happen? Just look at these mangoes. Right now, they look absolutely perfect. But you and I both know that in a few days, something's gonna change. They'll get all soft, start to turn brown, and, eventually spoil. This whole process, this is our first big clue in a much, much bigger puzzle. All right, so every good detective knows you've got to look for clues to solve the mystery. Let's start by hunting down the secret ingredients, the real culprits behind all these changes. Now, here's where it gets really interesting. This whole thing, it's not just about food. Have you ever seen an old bike or an iron gate that's been left outside in the rain? It gets that kind of brownish, flaky coating on it. Well, that change has a special name. We call it rusting, and it's another key piece of our puzzle. And boom, here is our first major breakthrough in the case. After a ton of experiments, scientists figured out the two secret ingredients that you need for rust to happen. And get this, it's not just one or the other. You absolutely need both water and air. We found our culprits. Let me show you the proof. In one test, you take a nail and you only give it dry air. What happens? Nothing. No rust. In another test, a nail with only water, again, no rust. But the moment you put a nail where there's both air and water, bam, rust appears. This is how we know for sure what our secret ingredients are. So, okay, we found our ingredients. But, that just leads to an even deeper question, doesn't it? What is it about air and water that makes them so powerful? To figure that out, we need to zoom in. I mean, way, way in. Welcome to the next level of our investigation, everybody. We're leaving behind the world we can see, and we're diving into the invisible world of atoms, the tiny, tiny building blocks of, well, everything. No, really. The screen you're looking at, the air you're breathing right now, even you, it's all made of these countless, unbelievably small particles called atoms. You can think of them as the Legos of the entire universe. Now, what's cool is that atoms don't really like to be alone. They're pretty social. They love to team up. And when two or more atoms link together, they form something we call a molecule. It's like a little team of atoms, all stuck together, creating something totally new. So for instance, carbon is a super friendly atom. It loves making bonds. Right here, you can see one carbon atom linking up with 4 hydrogen atoms. And when they do that, they form a brand new molecule called methane. It's this atomic team building that creates all the different stuff in the world. And there it is. That's the solution to our whole mystery. The rusting metal, the spoiling mango, none of this stuff is magic. It's just atoms breaking apart from their old teams and rearranging themselves to form brand new teams, brand new molecules. That's the secret. Okay, now that we've totally cracked the code, let's see this incredible atomic dance in action. Because once you know what to look for, you can find powerful examples of it happening all around us. Have you ever actually wondered how soap cleans your hands? It's amazing. It's all because the soap molecule is basically a secret agent. It has 2 different ends, a head that absolutely loves water and a tail that totally hates water but loves to grab onto oil and dirt. So when you wash your hands, the soap molecules form these awesome little traps called micelles. The tails all point inwards, grabbing all the dirt and oil, while the water-loving heads face outwards. This creates a little sphere that lets the water just whoosh. It washes the trapped dirt right down the drain. It's a perfect atomic heist. But rearranging atoms isn't just for getting clean. It's literally the secret to life itself. In a process called photosynthesis, plants take in really simple stuff, like carbon dioxide from the air and water from the soil. Then, using energy from the sun, they just rearrange all those atoms to build brand new molecules for food. And as they do it, they release the oxygen that we all need to breathe. So just think about that for a second. Every single plant you see is like this remarkable little factory. It's constantly busy, taking in simple ingredients, rearranging their atoms, and creating everything it needs to grow. And in doing so, it supports pretty much all other life on Earth. Just Wow. Okay, we've seen spoiling food, rusting metal, clever soap, and life-giving plants. We've investigated all the clues, and we've uncovered the atomic secret. So now it's finally time to give this incredible process its official name. Just think about it for a second. All these wildly different things, from a simple change in your kitchen to the process that literally powers our entire planet, they're all connected. They are all examples of the exact same fundamental secret.
And that secret is called a chemical reaction. That's it. It's any process where the atoms in your starting stuff just rearrange themselves to become completely new stuff with totally new properties. It's the engine of change in our universe.
And these reactions, this is what makes our planet work. The Earth isn't just a big rock floating in space. It's a dynamic, living system. Chemical reactions create this amazing balance between our air, our water, and all living things. It's what allows life to thrive in this beautiful, interconnected dance.
And now, one final puzzle for you, our master detective. You slice an apple, you leave it on the counter, and after a little while, it turns brown. You know now that this is a chemical reaction. So, based on what we figured out with that rusting nail, what do you think the secret ingredients from the world around it might be? Give it some thought and never stop asking questions. Keep exploring the amazing chemistry of change.